Hi, everybody. This is Don Wei. I have my colleague, Prasanth Pulla, with me. We have been doing, as many of you may know, the ServerReady program for quite a few years. And in today's talk, we're going to talk about how we extend the standards-based system architecture beyond the servers into the edge and client spaces. So, like I mentioned, we have been doing the server standards for 9 or 10 years now, and we launched the ServerReady program in 2018, and it consists of a number of specifications. The first one is the server-based system architecture. This is the hardware requirements for generic off-the-shelf OSs. And it was basically developed for the server systems initially. And it talks about the architecture and system architecture. And basically, it consists of the references to the ARM architecture, the ARM version A.X, the A-class systems, as well as the industry standards, things like the PCI Express technology. And we merged the two together so that we can build server systems with the ARM CPUs, the ARM interconnects, plus the industry standard PCIe technologies. And in the future, we are looking at the technologies such as CXL, C6, and Gen Z. Requirements related to those standards will come in as we integrate these technologies into the systems. On the firmware side, we have this thing called the server-based boot requirements. This is the minimum firmware requirements for the OSs or hypervisors. We have targeted Windows, Red Hat, VMware, but of course, SUSE, Ubuntu, many other operating systems are also working fine on the servers. And it was addressing the horizontal integration model where the OS vendors and the device vendors are, not necessarily the same. And so we need to have standard firmware interfaces to be agreed upon so that the OSs can just work on these platforms. So we based the design on the ARM architecture, the ARM specifications. We've got the trusted firmware, the PSCI SMCCC, some of the bridges that we built for supporting the industry standards like UEFI, CPI, and SMBIOS. We also support, the PCIe technologies, as well as, the trusted compute, TPM type of measured boot. So this is what we have. And like I mentioned, we launched the version 1.0 of ServerReady in 2018, and we have been checking the specification versions, SBSA version 3.1 and SBBR version 1.0. And we asked people to run the ACS testing, which is a test tool that we built, and it is open source. And we also asked for 2 distros of Linux installations to be done and installation logs to be sent to us for evaluation. And WinPE was later made public in 2019. So we are also recommending people to use the WinPE installation and give us the installation log for evaluation as well. The value of WinPE is that it is more strict in terms of looking at things that are ACPI and PCIe compliant. So it may find more issues where the Linux installations could tolerate. And then we are planning to launch the version 2.0 later this year. And originally it's planned for the Computex. And yesterday I just got the notice that the event is moving to September. But we are still looking at a launch in June. So this might just be a virtual launch. It's going to target SBSA version 5.0 and SBBR version 1.1. these specifications are available, 2 years ago, and we're checking against now the SBSA levels 3 to 5. And we're going to release the ACS, the test tool version 2.4 in the next week or so. And it allows you to check against these newer levels. And we're going to ask for OS installation logs also, but this time we are going to ask for the WinPE as a requirement. And then we're in the process of categorizing the OSs so that you can pick and choose from some clusters rather than the random selection, because if you just select Rio and Fedora, you're probably just telling us kind of the same issues. So the reason of asking for the Windows PE and distros of Linux installation is that this ACS tool is what we developed, and we think it is in the process of getting more mature, right? So there may be some interfaces that we didn't test sufficiently for the OSs. So we are checking with these Linux and Windows installation to see and improve on the ACS. Hopefully eventually we just need people to test with ACS, but I think as Linux and Windows grow, there may be still some discrepancies that we need to match. So we're going to monitor this situation as we go. So the main topic for today is go beyond the servers. So the overall strategy that we have is, we have been very successful for the SBSA and SBBR and target different, targeted server system, right? But it is only targeting a very specific slice of the overall ecosystem, literally the data center servers. We would like to take the concept and apply more generically to other parts of the market across the ecosystem, and especially defining a generic ARM platform. But we don't want to change the ServerReady because it's a well-known program, and people who are using this program are well aware of it. So we're not going to change what ServerReady is. On the hardware side, we currently have SBSA. We think we can extract from it the baseline, the BSA for the generic hardware target, and then we can build on top of it market segment feature sets. So SBSA will continue to exist on top of BSA to specify the requirements that are specific for the server market. And then we are going to introduce a CBSA, which adds a roadmap for the client features. So CBSA is going to build on top of BSA as well. So I have some diagrams to show in the next few slides. And on the firmware side, the situation is a little different because in the firmware side, it's not so much as market segment specific. It's really OS specific. So we're going to expand and include some of the common firmware interfaces, but at the same time recognize that different software stacks may require different recipes. So on the BSA front, when we started the SBSA, we have two main goals. One is to document a minimum set of CPU and system architecture for the OSs to boot and run. And the other one is to show a roadmap of levels that document an increasing set of hardware features following the progression of the CPU architecture. So we have literally combined these two goals together in the original SBSA. So you can see, we have progressed from, level 0 all the way to 6 right now. We're working on level 7. And so what we recognize is that there are many devices that want operating system to just work, but they are not necessarily all servers. So we're proposing to separate out the minimum hardware pieces from the SBSA, the first objective, and call that piece BSA. This is pretty much just the level 3 of the SBSA, but with some of the server specifics removed. And the BSA will become the minimum subset of the hardware needed to boot and run an OS. Of course, you need the firmware piece I'm going to talk about later. And then the SBSA adds the market-specific feature sets for the server market, and CBSA adds the client side, right? So this will be done in a completely compatible form. So if you are used to SBSA and you're continuing to build, SBSA required systems, compliant systems, you can continue to do that. It's going to be compatible, and you just use the BSA and SBSA together. So BSA, we expect that will advance over time, but it may be under a slower cadence, right? Because these kind of features are probably more stable. It will advance over time, but the cadence of which may be longer than the regular SBSA. And then the relationship with the CBSA is that, building on top of BSA, we are going to, basically develop the client-specific, hardware requirements. So as the ARM ecosystem move toward the laptops and, phones and tablets and maybe even desktops, we would be able to provide a standard platform architecture so that the OSs can just work as well. So systems are becoming complex enough that establishing a common system architecture for the key concepts is going to be very useful. And so people may have the question of, so which spec do I use? So the vision is that many OSs would treat the BSA as a target, and then the server ecosystem drives the levels in the SBSA, the client ecosystem drive the levels in the CBSA, and they may have different requirements for different areas of focus. And at the end of the day, they only offer kind of a handle for you to talk about the architecture requirements, and the adoption levels will be decided over time, and it will be following the market requirements, right? Different players, different markets may have different needs from these specifications. So you can think of SBSA and CBSA as profiles, and we may add additional profiles as we need. So the firmware side, we have looked at the landscape. So we have the SBBR, which is actually very successful. It's being used by many OSs. Some of the OSs require the SBBR. Other OSs can support SBBR or with other boot models as well, right? So I kind of put this picture together to show how the things are working in the field today. And so this is actually a very good indications of the successes for the SBBR. And then we're going to separate out the interface requirements, and then we can build different recipe for different OS needs. So the goal of the BBR, we're going to create a BBR document to cover the A profile market beyond just servers. We're going to establish some of the common interfaces requirements, the PSCI, SMCCC, as I mentioned before. Everybody is using that for ARM systems, right? And then we end on top of it, the UEFI, CPI, and BIOS requirements, which is used in the SBBR situation today. And we're also going to add the device tree requirements pointing to the device tree specification, because some segments of the A-class systems are supporting device tree technology. And instead of having the profiles, we call these recipes for the OSs. So the first well-known recipe is the SBBR, which is using the combination of UEFI, CPI, and SMBIOS to support the number of OSs that I specify here. Windows, VMware, Red Hat, Oracle, Amazon. A lot of these OSs require the SBBR. Some of the other OSs like SUSE, Ubuntu, FreeBSD, NetBSD, they can support SBBR as well. But we are in the process of introducing new recipes. So for some of the more embedded looking systems, it's easier to support a reduced set of UEFI, typically putting UEFI ABI on top of U-boot, and then they can support a device tree. Right, so this could be a recipe for that class of operating systems like Yocto. And then on the cloud, service provider side, we know Google and Facebook are wanting to have Linux boot to replace the Dixie side of the UEFI model. So Linux boot can be combined with either device tree or ACPI to support some of the OSs that these hyperscalers are using. So we may be providing a recipe on that front as well. And as other OSs are showing up, we may be able to take a look at what other recipes may be necessary. And so these two diagrams, I'll quickly just show the relationship. So EBBR is requiring a subset of UEFI, right? And then you can either combine with device tree or ACPI. And then SBBR is requiring UEFI, ACPI, and SMBIOS. So if you do SBBR, you pretty much satisfy the EBBR as well. And in terms of the Linux boot, it basically replaced the UEFI portion, especially the Dixie portion of the implementation. And then you can support the OSs that supports Linux boot. They can also put a UEFI ABI on top and make their system SBBI compliant as well to support other OSs. I think if you went to the open source firmware conference last year, Google showed a kind of a proof of concept of such a system booting Windows. So it's kind of interesting to look at these kind of relationships. And of course, to run these certification programs like ServerReady, we came up with the compliance test, right? So the ACS, the Architecture Compliance Suite, we're looking at reorganizing it into matching the BSA requirements, BSA document, and also the BBR recipes. So this is what I have to share with you today. Any questions?
In the chat, there was a statement from David. Awesome. Looking forward to seeing this take shape. So that's great feedback. Thank you.
Yeah, this is just the beginning. I think we would like to share with everyone as early as possible, but it will take a bit of time to have everything put together. We have shared some of the pre-alpha versions with the server AC community for the BSA and BBR. So this is just the work, the beginning of the work.
We have another question. Any plans to make the development of these standards more open?
Yes. So EBBR, if you take a look at it's already a community developed specification. Traditionally, the SBSA and SBBR are defined in this community called Arm Server Advisory Committee, the Server AC. The only requirement to join that committee is a standard NDA with Arm, but we are also in the process of looking at opening this Server AC up to be more like the Open Compute project, the way it runs. So we're in the process of looking at it. I'm not ready to share the launch date, but this is something that we're looking into.
So Dong, I think I just want to add one point to making the standards more open, at least for the BSA and BBR documents, is we just don't want to wait till the whole document is final. So we do plan to make early alpha and beta releases of the document somewhere on developer.arm.com. So that is in addition to making the server AC open, as Don already mentioned.
Yeah, this is a great point, Prasanth. So yeah, I think in the next few weeks, you may be able to see the alpha version, right? So we try to be more open to the process as much as possible. I think what Prasanth is talking about is another way, not waiting for the, or the opening up of the server AC, but we are also putting the spec, alpha beta versions to the public website as early as possible.
Okay, thank you. We have a question via YouTube. Wookie asks, what is the process of defining these specs, e.g. EBBR?
Yeah, so EBBR is a community-built specification today, and the spec is actually in some sort of a GitHub repository, and so you just go there and file the pull request basically. For the SBSA, SBBR, and in the future the BSA, BBR, we have the in the server AC group, we have the mailing list, we have meetings, we have Mantis ticket systems. So if you want to add new requirements or modify requirements, you can file what we call the engineering change requests into the Mantis system. And we have the members review them and go through a process of discussion. And if adopted, we will integrate into the next release of the document. So it's a well-established process. It's the community decision to make these, to adopt these engineering change requests.